In embedded Linux, we often use these terminologies such as Ramdisk, initrd, initramfs. Do you know what all these things are? Are you really puzzled over these things like what is initrd, what is Ramdisk, what is the usage of this? And the problem is the more you Google around these terms, the more you get confused. So in this video, I'm going to clarify all your doubts related to RAM disk. That is what the topic for today is, RAM disk. Hi everyone, I'm Pradeep Devani. I'm a trainer and consultant. To know more about me and the courses which I offer, refer the description of this video. And also I have the WhatsApp community of the like-minded embedded Linux professionals. You can join that WhatsApp community as well. The link for the same is available again in the description for this video. All right, so now let's right away jump into the core topic of RAM disk. All right. So RAM disk, what is actually RAM disk? As the name itself suggests, RAM disk is nothing but some portion of RAM which you have, you use it as if it's a disk. So the some portion of the RAM you use, you treat it as if it's a disk. Now, why would I like to do that? Why would I like to use some portion of RAM as a disk? Well, we'll come to that point, but before that, let's understand the typical scenario. In the standard case, what do we do? So in the standard case, what we typically have is we have something called the hard disk. And in the hard disk, we typically have the partitions. And one of the partition which we have, that partition we basically mount it over slash, and that becomes our root file system. The contents of this particular partition are the one which we becomes root file system, where you typically have bin, sbin, and all those kind of things. Now there might be scenarios where you typically don't have the disk, or let's say it has happened so like you have the disk but somehow it is corrupted and you want to perform the recovery of the same. So if on your board, if it is a diskless system, or there is a disk but it is very small and you can't use it for this purpose, what you will be using is you will be using some portion of RAM. You will be treating some portion of RAM as if it's a disk. Now, how does this things work? How does the RAM disk work? So typically what happens is, as you know, we have the bootloader. And what bootloader does is, bootloader will basically load this RAM disk image. So let's say I have got the RAM disk image over here in some flash drive, or let's say it is available on some PC and I would like to take that over the network. Okay, so whatever may be the case, let's say I have the image by name rdext2.bin, and what I will be doing is this rdext2.bin, I will be loading it. The bootloader will be loading it into the RAM. Now, let's say, for example, the address of this location where the RAM disk is loaded is this 8200 followed by 4 zeros. And now what bootloader does is bootloader passes the argument to the kernel, where it tells the kernel that your root file system, your RFS root file system, is on RAM. Now kernel during the boot up, what it will be doing, it will basically mount this particular content, these particular content which are there on the RAM, it will be mounting it on the flash. And that's where your root file system now is on the RAM disk. So that's what is the usage of this RAM disk. Typically, we use the RAM disk to recover our board. Let's say your board was working and somehow it has happened that your root file system got corrupted and you're not able to boot up. So in that case, what you can use is you can use this RAM disk for the recovery purpose, where you will be able to recover your board. So with the help of this, you can run some tools like E2FS disk, or you might also repartition this whole flash memory and can put the fresh contents on it and you can recover the things. So that's the purpose of the RAM disk. And in some of the products, we use the RAM disk as the final root file system. The reason we want to use the RAM disk as a final file system, again, the reason can be like, let's say you don't have enough of disk space, or another thing is, which is very important, you want to have the read only file system. That means my root file system, I want to have it as a read only, so that accidentally I should not end up corrupting it. So many of the products we can use this particular approach as well to make sure that the root file system is never corrupted. Okay, so that's about the RAM disk in general case. Now you might have also heard about the term called init RD. So you might have heard about something called init RD. Now, what is this init RD? Again, in init RD, this RD stands for RAM disk. So again, the fundamental is same. Some portion of the RAM, you will be using it as if it's a disk. So same concept, the concept remains same. Some portion of the RAM, you will be using it as if it's a disk over here. Now, why is this term init? So as the name itself suggests, init means initialization, something which is going to be used during the initialization of the system, and after that you don't need that. Now, what might be the scenario where you might need to have this kind of case, like where the RAM disk will be used only during the initialization and will not be needed further? Let's understand that. So if you ask me, see, when your system boots up, as you know, typically in order to make a transition from the kernel space, from the kernel to the user space, one of the thing which you need is you will have to mount the root file system. Why? Because in the root file system, you have the first user space process called init, and you basically need to run. The kernel basically needs to run this init, the first user space process, and that is what will help us transition to the user space. So now, as you understand, typically the scenario is like your root file system can be on any of the partitions. You can say it can be on the NAND flash, it can be on the NOR flash, it can be very well on some SD card, it can be on the eMMC or whatever. So as you know, your system can be booted from the various interfaces where the root file system can be located even over the network. So as you understand, now there are variety of possibilities where your root file system can be. It can be over the network, it can be over the NAND, it can be on the NOR flash, it can be on the SD card. So when you want to deal with all those things, so if you want to mount the root file system, if I want to mount the root file system on the slash, the first thing which I would be needing is the driver. Okay, I would be needing a driver for that disk or whatever interface is my root, where my root file system is located. Let's say if it is located on the network. So if it is located on the network, obviously I need the driver for the Ethernet card, network interface card, which I might have it on my PC. Then there will be a PHY and all those things I will be needing. Now, as you understand, the network card is available from the variety of vendors. And for all of those vendors, there is a different driver. So what do I do? That means like whatever vendors the network card belongs to, as you know, like typically just consider the case of your Ubuntu. Now, Ubuntu, you see, you just have a single ISO image to be working on any of your PCs. Now, on your PCs, you might have a different boards, right? Some on a laptop, the Ethernet card might be different. On your other laptop, it might be from the different vendor. It can be from the Athros, or it can be from Intel. It can be from the Realtek. So, how do I make sure that my single kernel image is capable of working on all the platforms without any distinction. You never do something like this, right? For HP laptop, I need to use this ISO image. For my Dell, I need to use this Dell model. This model, I will have to use this. You never do that. Otherwise, there will be hundreds or thousands of Ubuntu ISO images you will have to maintain. But what we have is we have a single image which is compatible with it. Now, coming back to our point, what does it mean is irrespective, irrespective of what PC you are booting up on or what laptop you are booting up your Ubuntu on, you have a single image. Now, how that is possible? Does that mean like in the kernel you will integrate all the drivers of the world which are available? Not possible. There can be some thousands of drivers. It's not possible for us to integrate all those drivers in the kernel. So what we typically do, we basically compile these drivers as modules, kernel modules, and these will be dynamically loaded at the runtime. Okay, so all these modules are going to get loaded at the runtime. That means when the kernel has booted up, after that you load them and you accordingly get the drivers for that. Now here comes the challenge. If you understand, typically where you place your module, you place your modules in the root file system. That means inside this root file systems, what I have is lib modules, and this is where your all drivers, all kernel modules will be placed. But now the problem is, in order to get these modules, you need the root file system to be up. But what I'm saying is, even to mount these root file systems, you need the driver. So do you see there is a circular dependency over here? In order to mount the root file system, I need the drivers. But to get the drivers, I need the root file system. So there is a circular dependency. Now, how do we overcome this problem? This is where you have something called init-rd. So as you understand, this init-rd is nothing but the disk on RAM. So what happens is, first, in order to boot your kernel up, in order to basically get you to the point where you can get the real root file system, you use the init-rd. The kernel uses init-rd as the temporary root file system. And what does the init-rd contain? Init-rd will contain the modules which will be there in the root file system as well. So same modules in the lib/lib modules in the init-rd will be available. Now, this is just the RAM. So you can have the Ramdisk driver integrated in the kernel itself. So using the Ramdisk driver, you mount this portion of RAM as if it's a disk. Now from there, you get the modules which are specific to the which can be basically required to mount your real root file system. You load that drivers, and accordingly what you do is you mount your root file system. Once your real root file system is up, what we do is we discard this init-rd. So that's why the term init-rd. Init-rd means initial RAM disk. That means only during the initial portion of during the boot up time, you will be needing this root file system. And once the real root file system is up, you will discard the init-rd. I hope this clarifies the concepts related to the RAM disk and init-rd. Now, in the embedded world, you also come across one more terminology which we call it as init ramfs. We call it as init ramfs. Now, what is init ramfs? Well, again, the concept remains same over here as well. This is nothing but the disk on RAM. Some portion of the RAM, you use it as if it's a disk. That's why this is also a kind of RAM disk, but it differs from the typical RAM disk in a way that this init ramfs, their root file system, is integrated as a part of kernel image. Now, what do I mean to say over here? So what happens is, as you understand, you typically have two images. You basically have something called Z image, okay, which is your kernel image, and then you have something called rdext2.pin, which I can say is your RAM disk image. So you have two different images which bootloader loads into RAM. Now, what if I combine both of these images into a single image? That means your kernel and root file system are being packed into the single image, and that's what we collectively call it as init RAMFS. So again, this is one of the way by which you pack the kernel and the RAM disk into a single image, and this is also the also very useful in order to uh, recover your board. And in many cases, we basically, instead of using RAM disk and loading two different images all the time, you just have to load the single image. But of course, what will happen is the image which you will be having, the collective image, the size of your kernel image will be more, because this root file system is embedded into the kernel. Okay, and this is one of the again popularly used mechanism in order to recover your board. All right, so hope now you are very clear about these terminologies of RAM disk, initRD, and initRAMFS. To summarize, what we have seen is RAM disk is nothing but the disk on RAM, where a particular portion of RAM you use it as if it's the disk. Why do we need to do that? There can be variety of reasons. One of the reason can be like I need to recover my board. Now, in order to recover my board, my corrupted file system, I would boot up with a RAM disk and I will repair it. In some of the cases, you need the RAM disk kind of things so that you can have a read-only file system, because whatever you change on the RAM will be again coming back, will again be restored back. So that's why there is no chance of your root file system getting corrupted during runtime. That is also the reason. So in this RAM disk category, we have seen three things. One is basically the RAM disk. Another one is the initRD, which is used during the initialization, during the boot up. And the third thing we have used is basically init RAM FS, which is basically a root file system integrated with a kernel image. All right, so I think now you should be very clear about this term and you can be very confident about this particular terminologies RAM disk, init RD, and init RAMFS. Hope you enjoyed this video. Like it and share it so that others guys can also get benefited from this particular video. Also, let me know in the comment if you have any queries, and also let me know if you have any further any what all topics you would be interested in, so that I can post the videos on that as well. Till then, goodbye, stay tuned and keep in touch.